Unit 6, it's just stuck kind of in the middle of algebra. And it doesn't relate very much to algebra, to be perfectly honest. It relates more to a statistics and probability course than anything else. We teach it now for one, because the state of Virginia wants you exposed to more statistics than most students get in their high school courses. And these topics are on the SOL, sad to say. So as we work through these, while you do not have to memorize formulas, because the formulas are on the SOL formula chart, you do have to know and understand the concepts and how to calculate all of this. Okay? Dispersion, measures of dispersion. Dispersion is how data is spread out around the mean. Remember that the mean is the average, right? So I take everyone's test score in here for Unit 1, and I divide by the number of students, and that gives me the average score on that particular test. Often what I want to look at, though, as a teacher is the dispersion of those data. Is everybody very close to the mean? Did everyone do really well overall? Or was it really spread out? Did I have students who failed, students who got perfect scores? People are everywhere. And that's what we're looking at. Mean absolute deviation, which is abbreviated MAD, very creative there with the abbreviation, is the average distance of each data value from the mean. This is our formula for math. It says the sum of the absolute values of each point minus the mean, all divided by the number of data points. Again, the formula is not important. You will have an SOL formula chart. What's important is that you know how to calculate it, and you understand that it tells you how spread out the data values are. Standard deviation has a symbol, lowercase sigma, from the Greek alphabet, and standard deviation is another value that shows how data deviates from the mean. Deviates or is spread out from. And just as a side note for a later lesson, this is used in standard deviation in bell curves. Here's our formula. This time, instead of taking the absolute value, we take the square root. And we are taking each data point, subtracting the mean, squaring that value, adding them all up, dividing by the number of data points, and then taking the square root. Again, the formula is not important because your calculator will actually do this one for you, which is really nice. And you're given the formula on the SOL. Variance is the standard deviation squared. And sure enough, if we take our standard deviation symbol and square it, we have our variance symbol. Alrighty, so we're going to use these data sets to calculate measures of dispersion, which means I definitely have to have my graphic calculator today. I'm going to quit out of lines, which is the last thing I was doing with my graphing calculator. Okay, stat going to put the first set of data. Negative 10, enter. 0, enter. 10, enter. 20, enter. 30, enter. Let's see here. We come back to stat. And we arrow to the right to calc. I want one variable stats, so I will press enter. And yes, I want all the basics to come up. Calculate. Okay, we get some good stuff here. Here's our mean. It's 10. We have the sum of all the numbers, which is 50. Right here, sigma x, 14.1421. This is our standard deviation. With standard deviation, we go 4 place values. So I'm going to come all the way here to the 1. I look at the 3, and 3 makes me stay the same. So 14.1421. Coming back, looking at our calculator, my mean was 10. Let's fill that in. Variance is just standard deviation squared, so that's going to be easy. I'm going to do 14.1421 to the second power, enter. Okay, again, we're going to go 4 place values, 1, 2, 3, 4. The 9 makes me round up, so 199.9990. Now I did all the easy ones first, to be perfectly honest. Mean absolute deviation takes a little more work. So let's go back to our calculators. Stat, edit. Now we have our data. So what I want to do now is arrow over and up so that I'm on the header for list 2. Second, catalog, and select absolute value, because I want the absolute value of all of these numbers. I'm going to take every number in list 1. So second 1 gives me list 1 minus my mean, which is 10. Very important to write that mean down at the start of every problem. If you press enter, this has gone ahead and found both the subtraction and the absolute value for you. Now we go back to stat, calc, 1 variable statistics, but this time I want list 2. Second 2. And this time when I look at it, my mean absolute deviation is 12. Okay, I did the absolute deviation part in list 2. Now I'm interested in the mean. The mean absolute deviation here is 12. Now let's talk about what this means. Okay, the mean absolute deviation is smaller than the standard deviation. And those are the two that we're usually comparing. Which one you use depends on your purpose. If you have an outlier, if you have something that's way out of whack from everything else, then mean absolute deviation is going to give you a better answer. So for example, if everyone on the test scores a 90 and you get a 20, that's an outlier because that's very, very different than everyone else. Standard deviation, we use that more often when we're doing z-scores, when we're comparing individuals. So which one you want really depends on your purpose for the data. Let's try another set. Set B. Alrighty. Stat, edit, arrow to the top, press clear and enter, and that deletes out all of your data values. There we go. For set B, 8, 9, 10, 11, 12. Make sure you press enter after the last number. stat, calc, one variable stats. I want list one. That's where I put my information. Alrighty, my mean is 10. Very first thing needs to be written down. Now, my standard deviation.
Teachers, please pardon this interruption.
Sorry about that, ladies and gentlemen. I paused out the announcement at my big school. So this is our standard deviation. We want 1, 2, 3, 4 place values. I look at the 1 and 1 makes me go down. So 1.4142. And now if I come back to my calculator, very easy to find that variance. 1.4142 squared. 1. Whoa. 1, 2, 3, 4. 6 is going to make me round up. And so I'm going to end up with 2.0000 because of all the rounding. Pretty interesting. Let's take a look at our mean absolute deviation. I have to go back to stat, edit, and this time I'm in list 2. Arrow to the top so you're in the header. Pick up your absolute value symbol. Okay, we want list 1, so second 1, minus our mean, which is 10. Arrow out from that absolute value sign and press enter. Now I'm going to say stat, calc, one variable stats, but I wanted to use list 2 this time around. So second 2, enter, enter, enter. Here we go. 1.2. This has become our mean absolute deviation. So take a look at something here. With data set A, we had a mean of 10 for both of them. But our mean absolute deviation is much, much smaller with the second set of data points than it is with the first set. Look at how spread out they are. Right, negative 10 all the way up to positive 30. That's pretty spread out. That's 40-point spread. Data set B goes from 8 to 12. That's only a 4-point spread. So much closer together, and our mean absolute deviation reflects that with a much smaller number. So does our standard deviation. It's much smaller because our data is much, much closer together. And that's the whole point here. Last one. Let's look at data point C. So we will go to edit. Sorry, stat, edit, arrow to the header, clear, enter. Arrow to the header, clear, enter. All right, set C. 1, 3, 12, 15, and 19. Stat, calc, 1. Make sure it says list 1. Mine doesn't. I have to change it. Okay. I have a mean of 10 again. Let's look at my standard deviation right here. 1, 2, 3, 4. 0 makes me stay the same, so 6.9282. Alright, let's go ahead and find our variance. 6.9282 squared. 47.99995 makes me round up. So this is going to become 48.0000. Goodness, lots of rounding with these lately. Okay, mean absolute deviation. Stat, edit, list 2, arrow to the header. Absolute value symbol. list 1 minus your mean, which once again is 10. Stat, calc, 1 variable stats, change it to list 2, 6.4. Okay, let's look at this in relation to the other data sets. Our mean is the same for all of them, but data set B has the smallest mean absolute deviation and the smallest standard deviation, and that makes sense. If this is my mean, 10, and it happens to be in the data set, well, the range here is -2 and +2, so we're pretty close to everything. When I look at data set B, my mean happens to be in the data set, but my range is -10 and +20. Sorry, -20 and +20. Much more spread out than -2 and +2. With data set B, my mean isn't part of the set, but when I look at how spread out this is, it's -9 and +9, so it's in the middle. And my mean absolute deviation and standard deviation reflect that. That's the important thing to get from this. So we have some practice. Finding the mean absolute deviation, mean, and standard deviation of each of these data sets. And I want you to do this on your own.